Hello friends, welcome to InfoShi channel. In this exciting session, we will learn all about significant figures along with the concepts. We will solve a KSET previous year questions, work through examples and understand the important rules in a simple and easy way. So let's get started. So our question is select the incorrect statement from the following. The statements are 22 books have a infinite significant figures. In the answer of calculation 2.5 into 1.25 has a 4 significant figures. Zeros preceding to first non-zero digit are significant. In the answer of calculation 12.11 plus 18 plus 1.012 has a 3 significant figure. So before cracking this question, let's learn some important concepts that are in this question. Mainly we need to understand some important things that are precision, accuracy and significance. These are, what is accuracy? Accuracy is how close a measured value is to the true or accepted value. Example, true value is 25 ml. So measurement 24.99 ml, 25.01 ml, 25 ml. These values are accurate because they are very close to the true value. So easy definition for this is accuracy is a closeness to the true value. So what is precision? Precision is a how close repeated measures are to each other regardless of a whether they are close to the true value. Example, true value is 25 ml. So measurement is 24.50 ml, 24.49 ml, 24.51 ml. These value are precise because they are very close to each other, but they are not accurate because they are far from the true value. Easy definition is precision, closeness among a repeated measurement. So here they'll see 24.50 and 24.49 and 24.51. They are optionally closing. That's why this is called, this is a precision. So that is accuracy and this is a precision. Okay. So KSET one line memory tricks. So they, if they ask in a KSET question, KSET exam, so you have to remember it in a one way. That is, accuracy means correctness. Correctness means in the same way, closeness, closely it will come. Okay. Precision means consistency. In options, the consistency will come. No, that is called a closeness. Sorry, consistency. That is precision. Okay. Now the main important our concept is that what are a significant figures. So significant figures or significant digits are the meaningful digits in the measured value that indicate its precision. So you remember the what is precision. Okay, in a simple definition you can say that significant figures are all the certain digits in the measurement plus the first uncertain digits. Okay, I thought you were not understand the definition what I said, no? So when we are going to deal with the examples, no, then we will get to know that. Okay. So before going to the examples, let's see the rules of significant figures are very important for a KSET and net chemistry. So let's see the rules with the examples. Okay. First rule says that all non-zero digits are significant. Okay, I repeat it. All non-zero digits are significant. So example is 25.67 have a 4 significant figures because all digits are non-zero here in this. Okay. 3, 4, 5. In this three significant figures because all are non-zero only. Okay. Rule 2. What says rules 2? Zeros between non-zeros digits are significant. Okay. Let's say example 1.002. These are four significant figures because 0 between non-zero digits are significant. Here 1 and 2 are non-zeros, are between about 0. So this totally it will come a 4 significant figures. Here 2.03. Here also 0 is in between of non-zeros. So 3 significant figures. Okay. So these rules are very important for your understanding the significant figures. So please, if you are not getting, just take a screenshot and learn about it. It will get you as soon as soon. Okay. Okay, let's go to the third rule, that is leading zeros. Zeros before the first non-zero digits are not a significance. Example 0.0056. Here significance figures are only 2. Leading zeros are not as significant. When the zeros will come first, that are not as significant. Only 5 and 6 become a significant. So the significant figures are only 2 there. Okay. Here we also you can see that 4 non-zeros are there, but they are not, they cannot be considered. So 4, 5 is a two significant figures. Okay. The rule, fourth rule is says that trailing a zeros to the right of a decimal point are significant. So this is also one tricky question, tricky rule it is. So whenever the decimals come, they to be in a right side. So then they can consider as a significant figure. So now 2.50, three significant figures because they are in a right side. Non-zeros are in right side. Sorry, so zeros are in right side, so 2.50 are three significance, and 5.00 it have a decimal, no? So and decimal and also zeros are in the right side, so they are a four significant figures. Okay, let's go to the fifth rule, that is trailing zeros in a whole number without a decimal point are generally not significant. What it says, 1.500, they are a right side but they did not have a decimal, means point 15.00 if it is, then it be the four significant figures. Now only two significant figures become 1 5, only these are the two significant, 1 5 are the significant figures. Double zero is there, no, that will be not be considered. So in the same way, um, 1 2 will be considered as a significance. These three are not considered as a significance. Why these are not considered as significance? Because the rule says that things. Okay, just read a once or a twice this rule, then you will be understand things what is happening here. Okay, rule 6. If a decimal point is present, trailing zeros are significance. See, if it is a decimal point is there and it be in the right side, then it's confirming that it is have a significant figure. So 1200.0, few five significant figures we can see here because only these are in a this have a decimal point and also it have a in the right side, that's why it is have a five significant figures. Let's go to the next one. Here the question is that select the incorrect statement from the following. 22 books have an infinite significance. I already explained it in a, I already said that question. Now break let's break the options and also check the incorrect statement. Okay, let's do it. 22 books have a infinite significant figures. It's a correct statement. Why? Why it is a correct statement? Reason is exact number obtained by a counting object like a 22 books, 5 apples, etc. have an infinite number of significance figures because they can be written as 22.000 so on with an unlimited precision. So, as I said in a rule, that is 22.00 sorry, so on zeros. Here there is a decimal and also non-zeros. Zeros are in the right side. So these are unlimited. So 22 books, when the statement says that 22 books have an infinite significant figure, that is a correct statement. So mm, that is a correct statement. See here, significant figures keys concept. 22 books. These 22 books have a exact numbers, no. It is not like it may be 22, 22.3 like that. It is not there. It is exactly 22. If it is exact 22, then it called as a infinite significant figures, and it is a correct statement. The next statement is that in the answer of a calculation 2.5 into 1.25 has a four significant figures. It is an incorrect statement. Why it is an incorrect statement? Let's see the reason. In a multiplication, the final result must be rounded to match the number with the fewest significant figures. This is a very tricky statement, that is uh, easily when we see the when we calculate it 2.5 into 1.25, the answer is all anyway 3.125. Here also they given a four significant figures, so we'll mark it when this mark it as a four significant figures. But what the rules is says that in a multiplication the final result must be rounded to match the number of with the fewest significant figures. This is a result, it has to match the fewest significant figures. So I'll clear it. Wait, okay, yeah. This 2.5 has a two significant figures and 1.25 has a three significant figures. So calculation 2.5 into 1.25, that is 3.125. Since the least precision factor here 2 and 3 two significant figures and three significant figures, in this which is the least significant figure? Here this is a 2 is a least significant figure. So our answer should be, our answer also be the 3.125. Here only two significant figures we can consider. So 3.1 is only the significant, not a 2.25. Okay, so since the least precision factor 2.5 has only two significant figures, the result must be rounded to two significant figures, giving 3.1, not a 4. So this is an incorrect statement. So B statement is incorrect statement. Okay, let's see the C statement that says that zeros preceding to first non-zero digits are significant. Okay, when we see it in an exam, if we given like this means we have to think in a twice way. So how, what they are asking the questions and how we can clearly understand the questions, and then we can try to solve this thing. So zero preceding to first non-zero digits are significant. It is also incorrect statement. Why it is incorrect? So reason is that zeros that appear before preceding the first non-zero digits are never significant. They only serve as a placeholders to show the position of the decimal points. So, in examples we can see is that in the number of 0.0025 are a non 0.00 are non-zero digits. Leading zeros are not significant, so it has only two significant figures, 2 and 5. But we before we saw that 2.5 25.000 means we are giving a it has a significant figures, but here no, we are not giving, because the rule says that when a decimals come at a in a right side, then we can consider it. But when a zero come in a left side, we cannot consider it as a significant figure. So the here only 2 5 become a significant figure. So first here the statement says that the first zero are also a significant figure, so that is an incorrect statement. So this is an incorrect statement, this one is an incorrect statement, and again we in previous also we got one incorrect statement. So let's see the dth one, what it is a correct or incorrect. Okay, in the answer of calculation, 12.11 plus 18.0 plus 1.012 has a three significant figures. What it is says, okay, that's it. It's a correct statement. Why it is a correct? In addition, the answer cannot have a more decimal place than the number with the fewest decimal place. Okay, we discussed about this concept in a previous statement also. That says here 12.11, 18.0 and 1.012. 12.11 have a two decimal places and 18.0 is a one decimal places, least precision precise, and 1.012 is a three decimal places. Calculation, 12.11 plus 18.0 plus 1.012 is equal to 31.122. Rounding to one decimal place gives here. Okay, the same way what we explained it in a previous manner, no, in the same way. Here there it is a precise, we consider it as a precise, and we are here we are considering it as a decimal places. Okay, so in this three, which is a least decimal place? Zero. Not only zero, one have a two decimal place, zero is only have one decimal place, and here it is our three decimal place. So we have to consider least precise. Which is a least precise in this? 18.0 is a least precise, not in a number way, it is in a decimal. After a decimal, how much numbers we are having, that will be the matter here. So the calculation answer is 31.122, but least precise or a one decimal place, so rounding one decimal place given only one. So 31.1, which has a three significant figures, 3 1 and 1. So this is a correct statement. So conclusion, the incorrect statements are B and C are a incorrect statement. So the correct option is B and C. Okay. Third one, that is B and C. So thank you for watching. Be tuned with us for our next excited session, part 3. Let's learn a lot of information about chemistry along with us solving KSET question papers. So please like, comment, share and subscribe our channel. So be stay curious, keep learning, keep growing. Bye bye. Thank you.